Hello everyone, now we have to discuss the next concept, that is capacitance. So, what is capacitance? It is the ability of a capacitor to store the energy in the form of electric charge in electric field. It is the ability of a capacitor to store the energy in the form of electric charge in electric field. So, in case of inductance we have magnetic flux in magnetic field, here we have electric charge in electric field, that is it. Or we can say ability, it is the ability of a capacitor, it is the ability to store the energy in the form of electric charge, that is it. Okay. So, what is the representation of this capacitor? Representation simple, we have two plates, we have two conducting plates, in between these two we have a dielectric medium, whether it is air, glass or mica, we have to discuss. So, this we have two conducting plates. Okay. So, this is positive, this is negative, means why we are getting positive and negative? When we provide the potential difference across these two terminals, we have a positive terminal for this, we have a negative terminal for this, that is it. Okay. What are the units? Units are nothing but farads, that is F, microfarad, millifarad, like that. Okay. Then the amount of voltage which is provided across this element is always directly proportional to the charge which is stored in that, which is nothing but Q is always directly proportional to the V. Q is directly proportional to V, right. So, in order to eliminate this proportionality, we have to introduce a term, that is capacitance, C V. So, we have to differentiate with respect to T, C into dV by dt. So, what is the formula for this? dq by dt, rate of change of charge, is nothing but current C into dV by dt, right. So, this is the charging current for the capacitor, this is the charging current for the capacitor. So, from this what is the value of V? So, dV by dt is equals to 1 by C I, right. From this dV is equals to 1 by C I dt, right. So, if you provide the integration between these two, integral I dt, we are going to get V is equals to 1 by C integral I dt, V is equals to integral I dt. So, this is the charging current of capacitor, this is the voltage across the capacitor V c, okay, 1 by C integral I dt. Then what is the power absorbed by the capacitor? What is the energy stored in the capacitor? So, before that we have to define 1 farad capacitance. See, this is 1 farad capacitance. This is definition for 1 farad capacitance. What is that? The capacitance is said to be 1 farad provided 1 coulomb of charge can be stored with 1 volt across the 2 electrodes of the elements. Provided 1 coulomb of charge across 1 volt between the 2 electrodes, then it is said to be 1 farad capacitance. Let us discuss the power absorbed by the capacitor, that is I is equals to C into dV by dt, we all know that. So, V is equals to 1 by C integral I dt. So, P of t is equals to V of t into I of t. So, from this P is equals to C into V, which is multiplied by dV by dt. Next, energy stored in capacitor, that is half CV square joules. From this we will get half CV square. In case of inductance we have half Li square, now it is half CV square. So, next, capacitor cannot disperse the energy, only it can stores it. Same like in the case of inductance. In case of inductance, inductor cannot disperse the energy, it can stores it. Same like that here, capacitor cannot disperse the energy, only it can stores it. Next one, it can stores the energy even the current through it is 0. Next we have to discuss about the parallel plate capacitor. Parallel plate capacitor. So, these two are metallic plates, okay, means those two are conducting plates, those two are conducting plates. In between these two we have to provide a medium. So, that is called dielectric medium, whether it may be glass, mica or what, air. In this case it is air, okay. So, in between these two plates we have a electric field. When we provide the potential difference between these two plates, obviously we have the electric field. So, supply voltage. So, because of the supply voltage between these two we have to get electric field, okay, electric field. These two are two metallic plates, means those two are conducting plates. In between these two we have electric field and we have a dielectric medium. We have a dielectric medium. That medium may be air, here we have air, glass or mica. That is simple, we have resistance, right? We have two parallel plate capacitor. So, this is one plate and this is another plate, that is it. So, in between these two we have to provide a medium. This is the medium between these two plates. This is the medium between these two plates, whether it is air, glass or mica, that is it. Okay. So, the distance between these two plates is nothing but d. Okay. So, the value of capacitor is proportional to the surface area of these plates, or you can write it and inversely proportional to the distance between these two plates. So, C is proportional to A by D. So, C is equals to epsilon A by D, epsilon A by D, that is it. C is equals to epsilon A by D, which is equals to C is equals to epsilon naught epsilon R A by D. Here epsilon R is nothing but relative permittivity. Here epsilon is equals to permittivity. What is this permittivity? It is the substance which is used to store the electric field. It is the substance, which is used to store the energy. Next, we have to analyze the circuit. Analysis. For example, we are providing a supply voltage. So, this is the capacitor, right? We have a switch. This is the supply voltage, this is the capacitor, that is the switch. Assume C is fully uncharged. When switch is closed, when switch is closed, there is a current. Because of that current, we have C into dV by dt, right? Charging can take place. It will slow the charge that capacitor. After fully charged, charging can take place. Charging can takes place, right? After fully charged, what will happen? The amount of charging can be discharged slowly. Why it is discharged slowly? Because it is having, after fully charged, it will start discharging very slowly over a long duration. Why? Because leakage current through it, because there is a large leakage current through it. So, when the switch is closed, charging can take place. After fully charged, it will start discharging very slowly over a long duration, because leakage current through it, because of leakage current through it. This is the analysis, simple analysis. Now, we have to discuss the important observations. Same like in the case of inductance, we have to deal with this observations. So, we all know that I is equals to C into dV by dt. The first observation is what? If the voltage across the capacitor is being constant, what will happen? The current would be 0. The current would be 0. That is, if V is equals to 0, if V is equals to 0, current is equals to, sorry, if V is constant, current is equals to 0. If current is equals to 0 means what? It acts as open circuited, right? That is, what is the condition here? That is, at the instant of switching with DC excitation, initially it is don't have any charge. That is, at the instant of switching, here we have voltage is constant, for that I is equals to 0 means open circuited. Voltage is constant means what? That is steady state, right? Voltage is constant, that is steady state. So, after some time we will get this steady state, but initially it acts as what? Short circuited. Under steady state it acts as open circuited means what? Initially it acts as short circuited. That is, at the instant of switching with DC excitation and with no initial charge, the capacitor acts as short circuited. But as soon as it will fully charged, it acts as, or it behaves as open circuited. That is it. Fully charged means what? The voltage which is equals to the supply voltage. See, in the analysis what? After when the switch is closed, the current is gradually increases till what? When the supply voltage is equals to the capacitive voltage, constant, right? When the supply voltage equals to the capacitive voltage, then after fully charging it will start discharge. That is the condition you have to consider here. So, with DC excitation with no initial charge, the capacitor acts as short circuited, but as soon as it will fully charged, it acts as open circuited. That is, when it is steady state, when it is open circuited, when the capacitor voltage should be equal to the supply voltage, that is constant, V is equals to Vc, right. So, what is the key point here? Initial state, final state, that is steady state. Initial state, final state. Here it acts as what? Short circuited. In final state it acts as open circuited. In case of inductance, in initial state it acts as open circuited, in final state it acts as short circuited, right. Just to interchange, that is it. Next, second point, if there is a minute change in voltage, if there is a minute change in voltage with dt is equals to 0, with less time, then the value of current would be what? Infinite, right. The same scenario like in case of inductance, the value of current would be infinite. So, it is physically not at all feasible. Therefore, here the point comes. Therefore, capacitor does not allow sudden change in voltage. In case of inductance, inductance does not allow sudden change in current. Here, capacitor does not allow sudden change in voltage, or we can say voltage in capacitor does not change instantaneously. Does not change instantaneously. Next point is, we all know that Q is proportional to V, which is equals to Q is equals to CV, right? Right? This is Q, this is minus Q, this is V, and this is minus V. This is what? Linear. So, capacitor is linear, passive and bilateral. Linear, passive and bilateral. Next, last one is what? Capacitor stores the energy in electric field. Just we have to compare the observations and what are the important note points in inductance concept as well as in capacitance concept. Then you have clear idea. Okay. Next, we will discuss factors affecting the capacitance. We all know that C is equals to epsilon A by D, right? So, first one is plate area. Plate area means greater plate area gives C proportional to area of the cross section. Greater plate area gives more capacitance, lesser plate area gives less capacitance, that is so this is having less capacitance, it is having more capacitance. So, next one is plate spacing. Plate spacing. Plate spacing. If the spacing between the two plates is less, we have more capacitance. If it is more, we have less capacitance. Here the distance between the two plates is nothing but D1, Here the distance between the two plates is nothing but d2. So, d1 is more than d2, therefore, C1 is less than C2. Here we have what? Spacing is more, therefore, less capacitance C1. Here we have more capacitance, that is C2. So, C1 less than C2. Next one, dielectric medium. Dielectric medium, that is depends upon permittivity. So, greater the value of permittivity, more the value of capacitance. More the value of capacitance. If we compare air and glass, for air the relative permittivity is 1, for glass it should be approximately 7. So, for this more capacitance, for this less capacitance. Now, we have to look into summary. The summary is very, very important. Okay. So, we have initial state, and final state, that is steady state, right? We have initial state and steady state. Consider the element inductor, next capacitor. So, for inductor, when we provide the DC excitation at the instant of switching, that is initial state, it acts as what? Open circuited. Under steady state, it acts as what? Short circuited. Simple. If you do not have any idea with respect to this initial state, final state, just steady state, write that V equals to L into di by dt, this equation in case of inductor. Steady means what? The current is equals to constant. Okay? If current is constant, V is equals to 0. If voltage equals to 0, it acts as short circuited. So, under steady state, it acts as short circuited. So, in case of capacitor, when the instant of switching, it acts as short circuited. Under steady state, it acts as open circuited. For this, I equals to C into dV by dt. If V equals to constant, I is equals to 0. If I equals to 0, it acts as open circuited, right? Open circuited. That is the logic. Simple. Open circuited, short circuited, just interchange, you will get the other state condition. If you remember the conditions for inductor, obviously you will get the conditions for capacitor, just interchange that conditions, that is it. Okay. Next, VI relationships of all elements. That is circuit element, voltage, current, amperes, power, watts and energy, joules, right. The circuit element is, for example, first element is R, no? What is the voltage in that? V is equals to I into R. What is the current? I is equals to V by R. What is the power? P is equals to I square R, which is equals to V square by R. What is the energy? W is equals to I square R into T, which is equals to V square by R into T, right. Next, L. From this, V is equals to what? L into di by dt, right. Then what is the current? 1 by L integral V dt from this. Next, what is the power? Vi, no? L into I into di by dt. What is the energy? Half L I square. That is it. Next, C. Next, C. From this, what is the voltage? E equals to 1 by C integral I dt. What is the current? C into dV by dt. What is the power? V into C dV by dt. What is the energy? Half CV square. This is the summary of all elements. Okay.